Yes, guys. So we are continuing with question number 9 here. Okay. So in the ninth, we were talking about convex polygon. So convex polygon. What is a convex polygon? A regular polygon. Regular means which is having equal size in length. If it is having equal length of the size, then it is a convex polygon. How convex polygon is again defined? That if I draw a straight line which is intersecting this polygon, then it will intersect the polygon only at 2 points, or 2 lines are intersected by this. It will intersect the 2 lines of the 2 sides of the polygon. If it intersects the 2 sides of the polygon, that is known as a convex polygon. So this is a convex polygon, and it can happen only in a regular polygon. Regular means which is having equal sides. Okay, this is what you call convex polygon. And what is concave? In case of concave, if a straight line can intersect the polygon, okay, the 3 sides or more than 3 sides, more than 2 sides we can say. If a straight line is intersecting more than 2 sides of a polygon, that polygon is known as concave polygon. Okay, this is the basic definition of concave and convex. So this is how, this is a convex here. Concave, let me draw a concave polygon. And what is a concave polygon? Let me project. If I take a polygon like this, okay, this is a polygon. If I draw a straight line like this, now this is intersecting the sides of the polygon at one point, one side, this second side, third side, fourth side, fifth side, sixth side. So 6 sides are intersected by the straight line in this case. This is a concave polygon. This is a concave polygon. If I take the different sides A, B, C, D, E, this is a polygon here, F, G, and this is H. If A, B, C, D, E, F, G, H is a polygon having sides which are of different lengths, this is a concave polygon. The concave polygon, first definition is having sides which are of different lengths. Okay, they are not of equal length. And in case of convex, it's having equal lengths. Second thing, second definition is if a straight line is drawn, and that straight line is intersecting only 2 sides of the polygon, that polygon is a convex polygon. This is convex here, and this is concave if the straight line is cutting more than 2 sides of the polygon. More than 2 sides. Now in this case, this is cutting the 6 sides of the polygon. Okay, this is how concave polygon is there. Now what is the length of the regular polygon? Only in case of regular polygon we can find out what the total, sum of the angles of internal angles we may say. Now there are certain facts regarding polygon. Facts about polygon. Okay, if I just clean this, that will give us a proper view. Let me just clean this. Okay, now just some facts regarding polygon. First of all, suppose a regular polygon is there. This is a regular polygon I am taking. Then this is 6-sided figure. 1, 2, 3, 4, 5, 6. Okay, this is 6-sided figure. Let me take 6-sided figure. Then, with the sum of these angles, interior angles, sum of the measurement of all the interior angles of a regular polygon, let me talk about that. First fact is sum of measurement of all the interior angles, of a regular polygon, of n sides. And take number of sides is n, is given by the formula 2n minus 4 into 90 degree. This is sum of all the angles. So here there are 6 angles, 1, 2, 3, 4, 5, 6. Now if it is 6 sides, means n is 6 here. 6 to the 12. 12 minus 4 is 8. Okay, 12 minus 4 8. 8 into 9, 720. This is equal to, if n is equal to 6-sided figure, or 6, this is hexagon here, sorry, this is known as hexagon here, because hexagon means 6 here. Okay, so hexagon, this is hexagon. Hexagon means 6-sided figure. Okay, so 2n minus 4 into 90 degree. That means n is 6, 6 to the 12. 12 minus 4 into 90. That means 8 into 90. This is equal to 720 degree total sum of all the angles. This is regarding polygons, total sum of all the interior angles. Second point, each angle, or measurement of each angle. Each angle or each interior angle, let me take each interior angle of a regular polygon, is equal to, suppose n side, I am taking n sided figure, this is general formula, 2n minus 4 upon n into 90. Try to understand. For example, if in this case 720 upon 6 if I do, and here is 120 degree. Okay, so this is the formula, 2n minus 4 upon n equal to 90 degree of n-sided figure of a regular polygon of sides n is equal to this formula. For example, in this case, each angle will be what? Total angle is 720 degree upon 6, because n is 6 here. 6 1 just 6, 6 to the 12, 120 degree. This is 120 degree, 120 degree each. Each angle is 120 degree, 120 degree, 120 degree. Okay, so this is how interior angle of any regular polygon is calculated. If sides are n, the formula is 2n minus 4 upon n into 90 degree. Okay, so this is what we talk about interior angles. Okay, second fact. Now let me take third fact. Now fact number 3. What is that fact number 3? Let me just talk about that. If I just, one fact is that if I extend the exterior, the sides, then the exterior angle is this. Then if all the sides are extended and exterior angles formed, these angles, this angle, this angle, sum of all these exterior angles of a regular polygon is 360 degree. Third number fact. Fact number 3. The sum of all the exterior angles of sides, extended sides extended, of exterior angles of sides of a regular polygon, is equal to 360 degree. This is 360 degree. Okay, so of a regular polygon is 360 degree. This angle plus this angle plus this angle plus this angle plus this plus this. 6 angles. 1, 2, 3, 4, 5. All these 6 exterior angles of a regular polygon is 360 degree. Always, if the number of size is increased, then this would be diminished. I mean, it will be smaller, but sum and number of HTML will be increased, but measurement will be decreased. So in this way, total sum is 360 always. This is one of the facts here. Then fourth point. Now, what is the other thing? Let me just talk about. First, let me change the marker. Okay. First, if I change the marker, okay. Then next thing is number of diagonals for a polygon. A polygon is having, for the polygon, if any two sides are other than two adjacent vertices, if two vertices of a polygon are joined, then diagonal is obtained. This is diagonal, this is diagonal, this is diagonal, not this. Okay, so other than the two adjacent points or vertices of a regular polygon are joined, then we obtain number of diagonals. For example, in this case, how many diagonals are there? This is 1, 2, 3. Then if I join B, 4, 5, 6. Okay, then only this one. Otherwise, because if I join this C, same will be repeated. So how many were obtained at the moment? We have obtained here 1, 2, 3. Then by B, 1, 2, 3. Total 6. Because if I join C, then C will give us the same. Is for this was okay. This was the same, but this is not same. So this is one more, only 2 more are obtained. In this way, total number of diagonals. Okay. If I join, let me take number of diagonals. Diagonal of a regular polygon. Is obtained by joining two vertices other than by joining any two vertices. Joining any two vertices other than the adjacent one. The adjacent one. The non-adjacent vertices are joined. Non-adjacent means we cannot join AB. AB is a side only, not diagonal. But AC, this is diagonal. AC, sorry, this D. ABC, I'm sorry, this is D here. And this is E, and this is F. This is F E. Okay. So AC, AD, AE, 3. And by B, we cannot join B to A, but BC, BE, BD, not BC. Okay, so this is how we obtain the diagonals. Number of these diagonals, what is other than the adjacent, okay, the diagonal is thus obtained. So number of diagonals, of a regular polygon, is given by n into n minus 3, by 2. This is by 2 also. For example, in the case of this 6 minus 3 is 3. 3 into 6 means 3 into 3, 9. Total number of, if n is 6, then this is 6 into 6 minus 3 means 3. 6 equal to 6 into 3 upon 2. 2, 3 are 6 means 9. Total number of diagonals will be 9 here. So what is that? AC 1, 2, 3. Then by BC 1, 2, 3, 6. Then C. A is the same. So this CD will be, CF will be there. C, E will be there only 2, 6 plus 2, 7. Then joining D, D for DA and DB we have already obtained. Only DF is under 1, so 8. Then if I join E, E joined to the A, okay, we have obtained. EB we have obtained. EC we obtained only. Okay, so now let me join F. F2 B we obtained. FC we obtained. FD we didn't obtain. Only FD is obtained. Good. FD is another one. So the total 9 are there. Okay, so this is how number of diagonals is obtained by the formula n into n minus 3 upon 2. This is number of diagonals of a regular polygon. Number of diagonals is obtained in this way. Okay, every angle, interior angle is obtained by giving the formula 2n minus 4 upon n into 90 degree. Okay, and total sum of measurement of all the angles is 2n minus 4 into 90 degree only. The 3 important formulae for regular polygons. Okay, for the regular polygons. So this is how we have obtained regular polygons measurement. Now let's take other thing. Next question. So this ends the polygons. Some facts regarding polygons. We have talked about what do you mean by polygon. So concave, we have talked about what is convex polygon. All these two things we have talked about. Some facts regarding polygons I have talked about. So if there is a polygon of n-sided figure or n-sided polygon, n number of sides are there. N is just for general category, and we can replace by 3, 4, 5, 6, and so on and so on. Okay, so polygon can be more than 3 or 3-sided. 3-sided is a triangle. Okay, 3-sided figure, if it is there, it is a triangle. 4-sided quadrilateral. If it is 5 sides, then it is a polygon, regular polygon. Each side is equal. And then hexagon, heptagon means or septagon we used to say, but it is heptagon, 7-sided figure. Octagon, 8-sided figure. Nonagon, 9-sided figure. Okay, then so this is how decagon, also they are 10-sided figure. So in this way, number of polygons can be obtained by changing the value of n. N is number of sides here. Okay, so this is what we have obtained. Question number 9. Let us talk about next question, which is again very important one. So this is a bit information regarding these geometrical figures, which is very important. We will talk about areas, okay, perimeters of circumferences, etc. Next lecture series, we see that. Okay, and there we will discuss a lot of things which are very important again. So this is regarding polygon. Now let us take question number 10. What does question number 10 say? Now question number 10 is, okay, question 10 says, what are the interior angles of the following? Regular pentagon. Okay, let me talk about this simple one. What are the measurement or values of, what are the interior angles? What are the interior angles? Interior angles of the following. Values of the interior angles. What are the interior angles of the following? Values of the interior angles. What are the values or measurement of the interior angles of the following? Okay, so number 1, it has given solution on finding out directly. First is pentagon, regular pentagon. It says regular pentagon. Pentagon is 5-sided figure. I'll just talk about. Then B, it says regular hexagon. Regular hexagon are just the example there. This is regular hexagon. A regular hexagon. Hexagon 6 here, 6-sided figure. Then regular octagon. Only 3 points are there. Regular octagon. Octagon means 8-sided figure. So first point is solution I'm finding out pentagon. The formula is what? 2n minus 4 into 90 divided by n. This is the formula. This is since formula for measurement of interior angle of a regular polygon. This is a regular polygon. Is given by this formula. So if I put n equal to, when, let me write here now, when n is equal to 5, then suppose measurement is d degree. We have taken a degree or d degree. Let me take a small a degree. Therefore, a degree is equal to measurement of each angle of a pentagon. N is equal to 5. Then this is 2 into 5 minus 4 upon 5. N is 4. Sorry, n is 5 here into 90. This is 2 5 is 10. 10 minus 4 6. 6 upon 5 into 90. 5 1 ja 5, 5 8 40, 18 into 6. This is 108 degree. 6 8 48, 8 4 carry 6 from the 6 and 10. 108 degree. Each angle of a regular pentagon is 108 degree. And about hexagon I have already found out. And when n equal to, okay, let me again calculate this, n equal to 6, then so this is b degree here, b angle, b, taking b option. This is b degree equal to angle of the hexagon. Each interior angle of a hexagon is given by this formula. B degree is equal to 2 into 6 minus 4 upon 5 into 90 degree. This is 6 to the 12. Okay, 12 minus 4. 12 minus 4 is 8. 8 upon 5 into 90. Again, this is 18 degree. Sorry, this is what I'm doing, 6. So divide by 6. 8 upon 6 into 90. Now 6 1 is 6. 3 6 5 30. 18 5 120 degree. Each angle of a hexagon, regular hexagon, each interior angle of a regular hexagon is 120 degree. This is B part here. In case of a regular octagon, C point here, when n is equal to 8, then when we take each angle is C degree, measurement of each angle of a regular hexagon is C degree, because this is C part. I've taken C degree equal to 2 into 8, 2n minus 5, 4 upon 8 into 90. So it is 2 at the 16, 16 minus 4, 12, 12 on 8 into 90. Okay, 8 to the 16, 16 minus 4, 12. Now 4 3 are 12, 4 to the 8, 90 to the 45, 3 into 45 degrees. This is equal to 3 5 is 15, 5 1 carry, 3 4 is 12 1. 4 is 12, 12 and 1, 13, 135 degree each. Of a regular octagon, each angle is 135 degree. Each interior angle of a regular octagon is 135 degree. This is the answer here. Okay. All the three values we have calculated. This is the formula which we have to know about. Twice n minus 4 upon n into 90 degree right angle. Okay, that is what we have to calculate. So this is question number 10 we have completed. Now let us talk about question number 11. Now question number 11 says, what is the question number 11? Let us talk about. Okay, now question number 11 is having, what do you mean by the following facts about circles? Yeah, circles I'm going to talk about. First is 10th question, for 11th question, what do you mean by the following facts about circles? Chord, diameter, tangent, secant. Intersecting circles, common tangent to the intersecting circles, arcs, sectors, segments of a circle, etc. So let's talk about all the things. Question number 11 is lengthier one. What are the following? What are the following facts of following facts about circles? This is about circles only. So first point is to talk about what is the first point. It has asked is chord. B is the after chord we have taken diameter. We have got of a circle, diameter of a circle, what is chord of a circle. C point is all the basic one, tangent. What is the tangent here? Then D point is secant. What is the secant here? Secant. Then E point here. E point is intersecting curves, circles. Talk about what is the intersecting circles. Circles can cut each other, intersect each other internally, externally, or non-intersecting circles. How many tangents are there in that case? So arcs. What are the arcs here? Then common tangent to the. Okay. Then F part is common tangents. Common tangents. Number of common tangents. Common tangents to the intersecting circles. To the intersecting circles. To the intersecting circles. This is F here, then G. Intersecting circles. Okay. Common tangents are how many? Common tangent to the intersecting circles. Then arcs. What about arcs then? Then H is sectors. What are the sectors here? Sector of sectors. Then I. The last point in this case we are taking segment. Segment of a circle. What is segment of a circle? Segment of a circle. Now, first of all, let me talk about a circle. Circle is a path of a point which moves in such a manner that its distance is locus of a point or path of a point which moves in such a manner that suppose this A point is moving, which is moving in such a manner that its distance from a fixed point remains constant. So, circle, what is the definition? This solution here. Okay. Circle is a locus or path. Locus or path is the definition of a point which moves in such a manner that its distance from a common point, from a fixed point remains constant. Alright, remains constant. So this fixed point is known as center of the circle. Let me write here the fixed point. First is this is definition of a circle. The fixed point is known as center of the circle. Center of the circle. Center of the circle, and the fixed distance remains constant. And the fixed distance or constant distance is radius. Is the radius here, and the fixed or constant distance. Let me write here, and the constant distance. Constant distance is the radius. Is the radius of the circle. This is one of the radius of the circle. This is the radius. So this point A is moving in such a manner, or is having a path or locus. This is locus of a point or path of a point A. Let me take A, which moves in such a manner that its distance from a fixed point remains constant. Now this fixed point is known as center of the circle, and the constant distance is the radius. Okay, so this is the radius, which is noted by R. We have taken. Note the chord here. Now if I take any 2 points on the circle, suppose let me take this is BC. Now if I join this center to these 2 points, now this is the arc, any part of a circle, okay, or any 2 points lying on a circumference of this is known as circumference of the circle. This circumference, means around, circumference of the circle. This is circumference of the circular path is known as circumference. The circumference. Okay. So any 2 points lying on the circumference of the circle, and the joining of these 2 points which are lying on the circumference is known as arc. This is the arc here. Arc is a part of a circle between 2 points. You can say this is arc here. What are the arcs here? Any 2 arcs can be taken. It can be minor arc or major arc. Minor arc is, if I take a semicircle for example, a semicircle is the equal arc or equal arc. We may say semicircle is the equal arcs we are having. Other than this equal arcs, we can have minor or major arcs. Suppose this is less than diameter, okay, or which is the semicircle. I mean, less than semicircle, it will be minor arc. If it is more than semicircle, then it will be major arc. Okay, so this is how it divides into 2 parts: major arc and minor arc. This is minor arc. Other remaining is major arc. If I join CB or BC, BC is minor arc and CB is major arc. Okay, so this is how minor arcs and major arcs are there. This is G part I have taken first. Now for the chord here, if I join 2 points lying on the circumference of a circle, if I take 2 points